Look up at the night sky, what do you see? Thousands of twinkling lights, each one a distant star, a beacon of light in the vast darkness of space. These are stars, giant balls of burning gas that light up the universe. They are the cosmic lighthouses guiding us through the night. They are incredibly far away, but their light still reaches us on Earth, traveling across the cosmos for millions of years. Stars are not just beautiful to look at, they are the storytellers of the universe, each one holding secrets of the past and clues to the future. They are important for life itself. Without stars, the elements necessary for life would not exist. Stars are like giant factories, forging elements in their cores through nuclear fusion. They create all the elements that make up everything we see around us, from the oxygen we breathe to the carbon in our bodies. That includes you and me. We are all made of star stuff, remnants of ancient stars that exploded long ago. Without stars, there would be no planets, no life, no us. They are the architects of the universe, shaping galaxies and creating the conditions for life. Understanding how stars live and die helps us understand our own place in the vast universe. Their life cycles are a mirror to our own existence. Stars come in different sizes and colors, each one unique in its own way. Some are small and faint, like tiny fireflies in the distance, barely visible to the naked eye. Others are huge and bright, like giant spotlights in the darkness, illuminating the night sky with their brilliance. Each star has a story to tell, a journey from birth to death that spans millions, even billions of years. Their stories are written in the light they emit, a cosmic narrative that we are only beginning to understand. Stars are not just scattered randomly across the universe, they are born in special places called nebulae. Imagine a giant cloud of gas and dust floating in space. This is a nebula. It's like a giant cosmic nursery, where baby stars are born. These nebulae are not calm and peaceful places though. They are filled with swirling gas, powerful winds, and shock waves from exploding stars. It's in this chaotic environment that stars begin their lives. Gravity plays a key role in this process. Gravity is a force that pulls things together. In a nebula, gravity pulls the gas and dust particles towards each other. As more and more material clumps together, the cloud gets denser and hotter. Eventually, the center of the cloud becomes so hot and dense that something amazing happens. A star is born. A star is not just a ball of hot gas, it's a giant nuclear reactor. Deep inside the core of a star, something incredible is happening: nuclear fusion. This is the process that powers the stars and makes them shine so brightly. Imagine tiny particles, smaller than atoms, smashing together at incredibly high speeds. This is what happens during nuclear fusion. Inside a star's core, hydrogen atoms, the simplest and most abundant element in the universe, are forced together under immense pressure and heat. When these hydrogen atoms collide, they fuse together to form helium, another element. This fusion process releases an enormous amount of energy, much like a giant bomb, but continuously. This energy is what makes the star shine and gives it its heat. Once a star ignites nuclear fusion in its core, it enters a long, stable period of its life called the main sequence. This is the stage where a star spends most of its life, happily fusing hydrogen into helium in its core. Think of the main sequence as the adulthood of a star. During this phase, the star is in a state of balance. The outward pressure from the nuclear fusion in its core perfectly counteracts the inward pull of its own gravity. The length of time a star spends on the main sequence depends on its mass. Massive stars are like gas-guzzling cars. They burn through their fuel quickly and have short lifespans. Smaller stars, on the other hand, are like fuel-efficient cars. They sip their hydrogen slowly and can live for billions, even trillions of years. Section 5. Red giants, stars in their golden years. Eventually, even the longest-lived stars run out of hydrogen fuel in their cores. This marks the beginning of a dramatic transformation in the star's life cycle, a process that can take millions of years. The star's core, once a bustling hub of nuclear fusion, starts to change as it exhausts its primary fuel source. When this happens, the star enters a new phase of its life. This phase is characterized by significant changes in both the star's core and its outer layers. The star's internal structure begins to shift, leading to a series of complex and fascinating transformations. It leaves the main sequence and begins to evolve into a red giant. This evolution is marked by the star expanding to many times its original size. The process is slow but relentless, as the star's outer layers swell and its core undergoes intense changes. As a star runs out of hydrogen in its core, the outward pressure from nuclear fusion weakens. This weakening of fusion pressure is a critical turning point, as it allows gravity to exert a stronger influence on the star's structure. Gravity, always trying to pull the star inwards, starts to win the battle. The balance that once existed between the outward pressure of fusion and the inward pull of gravity is disrupted, leading to the star's core contracting. The core of the star contracts and heats up, while the outer layers expand outwards. This expansion causes the star to grow significantly in size, becoming a red giant. The heating of the core also ignites new fusion processes in the surrounding shells of hydrogen. As the outer layers expand, they cool down and glow with a reddish hue. This cooling is due to the increased surface area of the star, which allows it to radiate heat more efficiently. This is why these aging stars are called red giants. Their enormous size and reddish color make them some of the most striking objects in the night sky. Red giants are much larger and cooler than their main sequence counterparts. Their expanded outer layers and cooler temperatures give them a distinctive appearance that sets them apart from younger, more stable stars. Some are so large that if they were placed in our solar system, they would engulf the Earth and even Mars. This immense size is a testament to the incredible changes that stars undergo in their golden years. Section 6. The Fate of Stars, a Tale of Two Endings. The fate of a star is determined by its mass. Low-mass stars, like our Sun, will end their lives relatively peacefully. High-mass stars, on the other hand, are destined for a much more dramatic and explosive demise. Low-mass stars, after their red giant phase, will eventually shed their outer layers into space. These layers will form a beautiful glowing cloud of gas called a planetary nebula. The remaining core of the star will cool down and fade away, becoming a white dwarf. High-mass stars, however, will go out with a bang. As they reach the end of their lives, these stars undergo a series of violent nuclear reactions in their cores, fusing heavier and heavier elements. Eventually, the core collapses under its own gravity, triggering a supernova explosion. Section 7. Stellar Remnants, Echoes of Giants. In the vast expanse of the universe, stars are born, live their lives, and eventually die, leaving behind fascinating remnants that tell the story of their existence. After a star dies, it leaves behind a remnant. These remnants are the echoes of the giants that once illuminated the cosmos. The type of remnant depends on the mass of the original star. Stars come in various sizes, from small red dwarfs to massive blue giants, and their fates are determined by their mass. Low-mass stars, those with masses up to 8 times that of our Sun, leave behind white dwarfs. These remnants are the final evolutionary state of stars like our Sun, while high-mass stars, those with masses greater than 8 times that of the Sun, leave behind neutron stars or black holes. These are the remnants of the most massive stars in the universe. White dwarfs are incredibly dense objects, about the size of the Earth but with the mass of the Sun. Imagine compressing the entire mass of the Sun into a sphere the size of our planet. They are the leftover cores of low-mass stars, made up mostly of carbon and oxygen. These elements are the byproducts of nuclear fusion that occurred during the star's lifetime. They slowly cool down over billions of years, eventually fading away into darkness. This process is incredibly slow, taking longer than the current age of the universe. Neutron stars are even denser than white dwarfs. They are the remnants of supernova explosions where the core of a massive star collapses under gravity. They are formed when the core of a massive star collapses during a supernova explosion. This collapse is so intense that protons and electrons combine to form neutrons. Neutron stars are incredibly small, only about 20 kilometers across, yet they are incredibly dense. But they can have twice the mass of the Sun. This means a sugar cube-sized amount of neutron star material would weigh about 1 billion tons on Earth. Black holes are the most extreme objects in the universe. They represent the ultimate fate of the most massive stars. They are formed when the core of a very massive star collapses to a point of infinite density. This point is known as a singularity. Nothing, not even light, can escape the gravitational pull of a black hole. Their gravity is so strong that it warps space and time around them, creating a region known as the event horizon. Section 8. A cosmic cycle, from dust to dust. The death of a star is not the end but rather a new beginning. The material ejected into space during a star's life and death, enriched with heavy elements forged in its core, becomes the raw material for new stars and planets. The cycle begins anew in the vast stellar nurseries where gravity pulls together the remnants of dead stars, along with fresh gas and dust. Within these nebulae, new stars are born, continuing the cycle of stellar life and death. This cosmic cycle is a testament to the interconnectedness of the universe. The atoms in our bodies were once part of stars that lived and died long ago. We are literally made of stardust, and we are part of this ongoing cosmic dance. Section 9. Our place among the stars. As we gaze up at the night sky, we are reminded of the vastness of the universe and our place within it. The stars we see are not just points of light, they are giant balls of burning gas, each with its own story to tell. We have learned that stars are born in nebulae, powered by nuclear fusion, and live out their lives on the main sequence. We have explored their different endings, from peaceful white dwarfs to explosive supernovae, and the strange remnants they leave behind. The study of stars is a journey of discovery, a quest to understand the universe and our place within it. As we continue to explore the cosmos, we are sure to uncover even more wonders and mysteries about these celestial objects that have captivated humanity for millennia.